All right, so today we're going to talk about the law of conservation of momentum. It's a little bit more difficult than yesterday, but a little bit easier, okay? And this is going to kind of build into tomorrow's when we talk about collisions, okay? When we talk about collisions, whether it be elastic or inelastic collision. So this kind of builds into this today. We're not going to classify them, but, momentum is always the product of the mass times velocity, okay? So the law of conservation of momentum states that that momentum does not change, okay? The momentum before and after a collision is the same. So we've got two equations here now. They're saying the same thing, okay? They're saying the same thing, but they're a little bit easier to use if you differentiate them these ways, okay? So if two objects collide and they stick together, the mass of the first object plus times the momentum of the first object plus the momentum of the second object initially equals the momentum of the first object plus the momentum of the second object finally, the final momentum. So we broke those down into M1, V1 because that's how you calculate momentum. Now, they're a little bit easier to do if they stick together, okay? Because they stick together, then they would have the same velocity, okay? If they stick together, they have the same velocity. So our first example in this is a 6-kilogram fish that swims towards and swallows a stationary 2-kilogram fish, okay? If the fish swims at 1 meters per second, what is the velocity immediately after lunch? What? So, well, let's work it out. So what is the mass of the initial mass of the first object? 6. So 6 times, what is the velocity of that fish that 6-kilogram fish? 1. So 6 times 1 plus, what is the mass of the second object? 2 kilograms. What is the speed of the second object? Stationary, so it's 0. Okay, so that is just plugged in the left side of this top equation. The bottom equation, because these things are stick together. If something eats, they're going to be stuck together. Okay, so we're using the second one. So equals, parentheses, the two masses added together, 6 plus 1 times, I'm asking for what is the velocity immediately after lunch, so the final velocity. So we'll label that as V2. Label that as V2. So I can simplify some of this out, can't I? I don't need this part of it, do I? Because 2 times 0 is 0. So I'm left with 6 equals 7 times V2. So 6 divided by 7, what would be the final velocity? You need a calculator. 6 divided. So solve this out, divide each side by 7. That's an algebra problem. What would be the final velocity? I need how many significant figures? 1. So it would be what? 0.85? It was 85 what? So that's not exactly 5, so it would round up to be equal to 0.9 meters per second. Okay, it's pretty simple, isn't it? The big thing is you have to determine if they're separate. You don't even have to do it. I could have done this equation and got the same answer. Just would have known that my V2s would have been the same. It would have been a little bit harder to solve algebraically, but you would have got the same answer. Okay. All right, let's do another one. Any questions about that one? Let's do another. Let me copy and paste my stuff out. Where's my mouse? So my equations are going to go away, but they're there in case you need it. There's my next question. A 81-kilogram football player moving at 6.5 meters per second tackles and collides a stationary 140-kilogram football player. What will be the speed of the football player the moment after impact? So I'll give you a second to write that down, and then we'll come back together. All right, so are these people colliding or separating? Okay, And they're staying together. So I'm going to use my M1 V1 plus M2 V2 equals M1 plus V1, M plus M1 plus V1 times parentheses V2. So what was my initial mass of the first object? 81. Times what was his velocity? 6.5. Okay. Plus, what was my other object? 140. What was its velocity? 0. So we know that that's really not going to matter. Okay, so I can cancel that out. Equals my two masses put together, 81 plus 140 times V2. So somebody tell me the answer. The whole answer, okay? All right, what's your answer?
I got
0. What? 40 meters per second. Is that what other people got? So you should have done, that doesn't sound great. 81 times 6.5 divided by 221. Yeah, that's wrong.
I did it.
So you should have done 81 times 6.5 divided by 221. And I got 2.4 meters per second. Okay.
Okay, so how do you calculate
81 times 6.5 divided by the sum of these two things, which is 221. Is that what you got? What'd you get? 0? How'd you put it in your calculator? 81 plus, no, you missed the times 6.5. Well, you didn't need a velocity over here. I'm talking about right here. The V1 right here was 6.5. So to solve it out, so that went away. So it comes, so 81 times 6.5 equals, so this simplifies out into 526.5 equals 221 times V2. Okay, that's just multiplying those two together and then adding those two together, and then you should divide it by 221. That's how you solve that one out. Next question. Actually, let me, yeah. Here's our next question. This is as hard as it's going to get. Give you a second to write it down, and then we'll come back together. All right, so this person here, here's the big thing is they are separating, okay? They are separating because it says they are separating. So I need to work all this stuff out, okay? So a little bit more difficult, just because a little bit more, not say difficult, a little bit more tedious to do, okay? So what's the mass of the first object? 81. What is the velocity of the first object? 6.5. Because we're saying he's moving forward, okay? We're saying he's moving forward. That's why he has a positive velocity. Plus, what's the mass of the second? 140. Times the velocity of the second one. Negative 4.5. Well, because he's going the opposite direction, that's why he has a negative velocity, okay? They're going opposite directions. That's why he has a negative velocity. Equals, what's the mass of the first object again? Same thing, we already know that, don't we? 81. What is the velocity after the collision? Negative 1.2. So, I'm about to run out of room. Plus, the mass of the second one was 140, okay? And then we are looking for V2, aren't we? So now I got some simplifying to do. So we know 81 times 6.5 is 526.5. We know that 140 times negative 4.5 is negative 630. Equals 81 times negative 1.2 is negative 97.2. Plus 140 times V2. So I need to do some more simplifying, don't I? So 526.5 minus 630 is negative 103.5. Equals negative 97.2 plus 140 times V2. Now what do I need to do?
I was gonna say, would you combine like numbers?
Got it. So yeah, these don't have variables. So now I've got to get this 97.2 over the other side. The opposite of subtraction is addition. So I'm going to plus 97.2 to each side. To the 103, because the 140 is a variable. Okay. So now that I'm gonna have to go over here and work. I apologize. I'm gonna have to go over here. And so now plus 97 point negative 6 point. So now I'm left with negative 6.3 equals 140 times V2. So I divide each side by 140. And his final velocity would be negative, two significant figures, that works out right, negative 0.045 meters per second. So they actually both end up moving backwards, don't they? Is what this tells us, correct? So that's your homework for today. Now, you have some questions like both of these today, then you have some questions from review from yesterday where it's just simple calculate the momentum. Okay, remember momentum? We calculate momentum all day today, mass times velocity. A lot of times though on your homework today, remember your mass needs to be in kilograms, your speed needs to be in meters per second. If it is not in those, you need to convert them. And you need to show your work, just don't put it into Google. Okay? So that forms is posted. Like I said, I posted the worksheet along with it in case you don't want to do it. Make sure you upload a picture of your work and let me know if you have any questions. That's today.
So we can just turn the forms in and then do the worksheet.